Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 11 of lesson number 8, motion. Now this part is going to be the last part for the lesson, so make sure you're revising it properly, because in this part we are just left with one activity and summary discussion and then like 10 exercise questions, right? So we are almost done with the whole lesson. Almost what we are done with the whole lesson. It's just that like the exercise part and the summary, like this is going to be the revision part for the lesson motion. Okay, so make sure that you all are revising each and everything properly and you know what exactly motion is. So now I want each one of you to please go through whatever notes you have in your book. Now notes might be like for 3-4 pages, right? So make sure you quickly have a glance through them, and if I tell you to write a note on equation for position velocity graph, you should be able to write that, you should be able to derive that as well. This is how your revision should be now. Okay, so now the concepts that you're going to see on slide, you have to think of that you have been given a task to write a note on. Now I'm telling you one question to write and describe motion in detail along with example. This is what I want you all to write, because that is the first thing that we started when we have like we learned when we started the lesson, right? So I want each one of you to write a note on motion and like give at least 3-4 examples for it. You like motion wherever you can see in the real life example. Okay, I hope every one of you are writing it. I hope every one of you have like are done writing about motion, and remember you need to include 3-4 examples of motion as well. And after that, once you complete with this, you need to write the equations, 3 different equations that we have studied. Like I'm taking your small test so that you yourself know how much like you are aware of, you'll come to know when you write the answer for it, right? I hope you all have started like writing the equation, because that equation part again is very important. Okay. So now we are going to revise everything. You have written a note on motion along with example. So here you can check with it whether you have included all the points or not, and quickly have a glance through it. Because today we are going to like at the end we are going to study a summary. So I'm going to show you the slides one by one. You have to revise each and everything so that when we do the summary part you're aware of each and everything. Okay. Then we discussed on motion along a straight line, and here we have like below the explanation part for that. So you can like they can ask you a question to write a note on motion along a straight line. So you have to explain this, that when an object, now here they have told that an object, you can take any object, a car, let's say a car. Okay. So when an object moves in a straight line with respect to observer, then that motion is a straight line motion. Now let's say they have explained over here that if a body starts from C, now at 25 you can see the C has been labeled, right? And it goes to A, which is at 60, right? And then come back to C again. Then the distance that has been traveled is 35 kilometer plus 35, because the person is going from C to A and that covers 35 kilometer, and then again from A to C will be 35, so it becomes 70 kilometers, right? but its displacement is going to be 0. The distance covered is 70 kilometers, but the displacement is 0 kilometer. Okay. After this, we discussed on this activity 8.1. So here you should be able to explain the observation, conclusion and explanation to it. Okay. After this activity 8.1, we discussed on activity 8.2 as well. So I want you all to please go through it quickly as well. After this activity 8.2, we discussed on like uniform and non-uniform motion. So on this slide we have the information on uniform motion. So I want you all to please go through it quickly. After discussing about uniform motion in detail, like I hope you're revising it as such that you know what is uniform motion. Now you're not going through the screen, you're just explaining it to yourself, becoming your teacher. Now I'm not teaching you anything, okay? So now, as this is the last part, you're revising it, you have to be your own teacher as if you're explaining it to me. The revision should be as such, okay? Then after this uniform motion, we discussed on non-uniform motion as well. So I want each one of you to please go through it as well. After this, like here I have showed you like the non-uniform motion in detail, right? So here we have information on rectilinear motion as well, and like what exactly is going to happen where, like if it's a case with uniform motion and non-uniform motion, right? And now remember one thing, that the other name for non-uniform motion is accelerated motion. What is the other name for it? It is accelerated motion, so you have to be like aware of it, okay? After this, we discussed on activity 8.3. So as I told you, you should be knowing about the observation, explanation, and the conclusion for it, right? So make sure you know it. After this, we discussed on measuring the rate of motion. So I just want you all to please go through it as well. So after that, after discussing measuring the rate of motion, we discussed on like calculating the average speed, right? So I want you all to please go through it quickly as well. After this, we discussed on like example 8.1. So here we have like how to calculate the average speed of the object, right? So the total distance has been given and the total time taken for like traveling that distance has also been given, right? So we can solve this example by calculating the average speed, and we know like average speed has been calculated by total distance traveled upon total time taken, right? So the average speed of the object, like here if you can see, the total distance traveled is 32 meters because travel it, like first it travels 16 minutes 16 meters and then again another 16 meters, so 16 plus 16 becomes 32. That is why the total distance traveled becomes 32 meter, and the total time taken is, earlier it took only 4 seconds and then after that 2 more seconds added, right? So it becomes 32 meters divided by 6 seconds, and when we calculate this we get the answer as 5.33 meter per second. Okay, so therefore the average speed of the object will become 5.33 meter per second. Now adding the unit is also very important. You should be knowing that whenever you calculate the average speed of the object, you need to write the unit as meter per second. Okay. After this example we discussed on speed with direction, right? So over here we have like the formula for calculating the average velocity, which is equal to initial velocity plus final velocity divided by 2. Okay, so average velocity is VAV, right? And that becomes equal to, now we represent initial velocity as U, final velocity as v, and divided by 2. So average velocity becomes equal to initial velocity plus final velocity divided by 2. So whenever we have to calculate average velocity, we are going to use the same thing. But you should be knowing like what are the letters that we like represent. Like U represents initial velocity, V represents final velocity, VAV that represents average velocity, and the, you can say the unit over here that we are going to use is meter per second. So either you can write it at ms minus 1 on the top, or m slash s, slash is meter per second. Okay. I hope every one of you are going through it. After this, like discussing with speed with direction, we discussed on activity 8.4. So I just want you all to please go through it as well. After this activity, we even discussed on this activity as well. So I want each one of you to please go through it quickly. After this activity 8.5, we discussed on example 8.2 as well. So I hope every one of you are going through it. I hope you all are going through it, because here we have the information on like converting kilometer per hour to meter per second as well. So you should be knowing this as well, okay? So please go through it everyone as well. After this we have example 8.3. Here also we discussed on like how to calculate the average speed and the average velocity, right? So I want you all to please go through it as well. Then we discussed on like rate of change of velocity. Now you have to write it for your own self. Okay, like what answer can you write for this? Like if I tell you to write a note on rate of change of velocity, what exactly will you write? Okay. Then after that we discussed on acceleration. So I just want you all to please go through it quickly. After this we discussed on activity 8.6. So I want you all to answer this as well. After this we discussed on example 8.4. So I just want you all to please go through it as well. Then we discussed on the graphical representation of motion, and I hope every one of you are going through it properly. After this, we discussed on distance time graph. So I just want you all to please go through it quickly. After that, we have this information given, that is distance traveled by a car at regular time intervals, and the time given is in seconds, right? 0, 2, 4, 6, 8, 10, 12. These are the time in seconds, and the distance in meter is given, like at 0, like in 0 seconds the distance traveled was 0 meters. In 2 seconds the distance traveled was 1 meter. In 4 seconds the distance traveled was 4, right? So based on this, we had to like plot a graph, like distance time graph, for a car moving with a non-uniform speed. So I just want you all to please go through it as well. After this, we discussed on velocity time graph. So I just want you all to please go through it quickly as well. After this, we discussed on like how can you draw the graph, because here we have the velocity time graph for a car which is moving with a uniform acceleration, right? So how can you exactly draw that graph? That information has been provided on this slide, and I want each one of you to quickly have a glance through it, because this slide is very important and it's going to help you with the graph for this velocity time graph. Okay, so please make sure that you go through it properly. I hope every one of you are going through it. So this is the graph that you're going to come up with, okay, where we have the velocity time graph for a car moving with uniform acceleration. Okay. Yes. After this, we have like two graphs which have been given over here, like velocity time graph of an object in non-uniformly accelerated motion. So I just want you all to please go through this graph as well. After this, we discussed on activity 8.7. So like you might have plotted the distance time graph on the basis of the information that has been provided. So here we have the stations which have been given and the distance that it has traveled, like when the time like the arrival time, departure time, and the distance. Okay, everything. So I just want you all to please go through it quickly. After this, like your again we have an activity 8.8 over here, okay, and on the basis of the information that they have provided, that is distance traveled by Firoz and distance traveled by Sania, on the basis of that information we again interpreted a graph over here, right? We plotted a graph. So you can just revise it, and like I hope now you have understood how to exactly interpret a graph, right? Then after that, we discussed on the equation of motion by graphical method. And if you remember, I I told you to like write the equations like when I started this revision part for today, right? So this is what I expected from you, and I hope you all have written this three set of equations. That is V is equal to U plus AT, S is equal to UT plus half AT square, 2as is equal to v square minus u square. Okay, these are the three important equations, and I hope like if you have checked it, you have written it properly. Okay, after this, like, I just want you all to go through this slide because we have like derived all the three equations in the next three slides along with the graph that we have, right? So I just want you all to please go through it quickly. After this, we discussed on like the equation for velocity time relation, that is v is equal to u plus at, and we went through that like through figure 8.8, that is the velocity time graph, to obtain the equation of motion. Okay, so I just want each one of you to please go through this quickly. I hope you all are going through it and you will understand it better if you look at the graph. Okay. Then we discussed on equation for position time relation, and for that we have the equation as S is equal to ut plus half at square. This is the equation that we have for position time relation. Okay, so we can obtain that using the graph that has been given just beside, where we have the velocity and the time on y and x axis respectively. So time is on x axis and velocity on y axis. So using that we can get the form, we can get the equation as s is equal to ut plus half at square. Okay. Then we discussed on equation for position velocity relation. I just want each one of you to please go through it, because there's a graph, there's no graph for this. So just go through it as well. And over here we have the equation as 2as is equal to v square minus u square. After this we discussed on this activity, example 8.5, where we have where we have to calculate the acceleration and the distance traveled by the train for attaining this velocity, right? I hope you all are going through it, because this can be trickier for you to calculate it, because you're going to use your equation over here, right? So make sure you go through the example very properly. Then we had this one more example where we calculated the acceleration and distance covered by the car in that time, right? Then we again have one example over here where the brake which was applied to the car, it produced an acceleration of 6 meter per second in the opposite direction. So if the car takes 2 seconds to stop after the application of the brake, calculate the distance that it has traveled. Okay, so here we are going to use the equation v is equal to u plus at. After that we have s is equal to ut plus half at square. Okay. After this, we discussed on uniform circular motion. Okay, so I hope you all are going through it as well. I hope every one of you are going through it. So here we came up with a formula, that is V is equal to 2 pi r upon t, and how we came up with that has been given on on the top of it, right? So we have already discussed it, so I want you all to please go through it. After this, now we need to discuss on activity 8.9 in detail. So see, what you need to do is take a piece of thread and tie a small piece of stone at one of its end. So like you can see the picture, okay? Then move the stone to describe a circular path with constant speed by holding the thread at the other end as shown in figure 8.10. So as you can see in figure 8.10, you have to do the same thing. You have to tie a thread to the stone and then you have to rotate it. Let's see. Now let the stone go by releasing the thread. Okay, and can you tell the direction in which the stone moves after it has been released? Do you think you will be able to tell the direction? So by repeating the activity for few times and releasing the stone at different positions of the circular path, check whether the direction in which the stone moves remains same or not. Okay, you have to check this, whether the stone will remain in the same direction or it will keep on changing. So what observation you can write over here is, the stone goes in a straight line motion perpendicular from the string. How it will go? Straight line motion perpendicular from the string, and after repeating the same process again and again, we see that the stone goes perpendicular from the center from different positions. So it's going to be like this. I'll draw it and show it to you. It's going to be like, suppose this is the circular direction. Okay, this is the center where you are standing, so it will go over here, and from here we are going to have east. What we will have? East over here. From here we will have south. Okay, so it's going to be like this. It's going to move, but remember, it's going to be perpendicular from the center from different position when we repeat it again and again. Okay, now what explanation you can write for this activity is, now because we have studied about uniform circular motion just before this activity, right? So in a uniform circular motion, the direction of the stone changes with time. What will happen? The direction of stone will change with time, and it results in change in velocity and acceleration. What it will result in? It will result in change in velocity and acceleration, and this creates an outward force on the stone. What we will have? We will have an outward force on the stone, and the string balances this outward force by producing the tension in the string. So the string is going to have some tension, because of which it's going to have an outward force and the stone will move outward. Okay, and once we release the string, it removes the tension force, and now the stone becomes free because the tension force has been removed. So in that case the stone will become free again, and as a result the stone makes a straight line motion and goes away from its circular path in perpendicular direction. What will happen? The stone will make a straight line motion and it will go away from its circular path in the perpendicular direction. Got it? So this is what will happen, and I want each one of you to please write it quickly. I hope every one of you are writing it, because after this we have the summary and then the exercise question. So I want you all to be please quick with it. After this, now here we have the like summary, so I just want you all to please go through it. Now if you remember, I told you what is important over in the lesson is you knowing about the motion, about the examples of it, about the SI units of it, and the equations which have been given. Okay, and lastly we had the uniform circular motion, so that is what has been covered over here, right? So I want each one of you to please go through the summary, and then I'll discuss the exercise question as well. I hope every one of you are revising, like going through the summary part. I hope you all have gone through the whole slide where we have the equation about the uniform circular motion, then about what motion is, and about the SI units and everything. You have been gone through it. Okay, so now I want you all to read the first question that has been given over here. An athlete completes one round of circular track of diameter 200 meters in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? What do you think? How will you calculate this? Now you should be knowing how you have to calculate this, because that is when you will be like able to say that you know the concept. Okay, you all have to try it once and then I'll help you with it. I'm going to let you know how to calculate this. Okay, so see, what you have to write is the diameter of the track given is 200 meter. The circumference of the track will become 200 pi. That means pi into distance. You have to like pi into diameter. Okay, that was the formula to calculate the circumference. So 200 pi, it becomes 200 pi. Okay, and distance covered in 40 seconds is 200 pi meters. So what will be the distance covered in 1 second? 200 pi divide by 40, because we have to calculate it for 1 second, right? So we'll divide that by 40 and then we can get that distance covered in 2 minutes and 20 seconds will be equal to, because when you calculate 200 pi divided by 40, you'll get the answer as 140. So 140 into 200 divided by 40 meters, and when you calculate that, you will get the answer as 2200 meters. Okay, so the number of rounds completed by the athlete in 140 seconds will be 140 divided by 40, that will be equal to 3.5. Okay, so now you know the final position of the athlete is at the opposite end of the track, right? So the net displacement will be equal to the diameter of the track, and the diameter of the track is 200 meters. Okay, so like you have to divide and multiply and you'll like able to get it. Then we have the second question as Joseph jogs from one end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds, and then turn around and jogs 100-meter back to point C in another 1 minute. What are Joseph's average speed and velocities in jogging from A to B and from A to C? So now first of all you need to write the given part. Distance covered from A to B is 300 meters. Distance covered from A to C is 400 meters. And time taken to travel from point A to point B is, we know it's 2 minutes 30 seconds. So 2 minutes 30 seconds, if you convert that into seconds, so it becomes 150 seconds, right? So time taken to travel from point A to C is 2 minutes 30 seconds plus 1 minute, because in another 1 minute, right? So it becomes 3 minutes 30 seconds, and if we calculate that in seconds, it will be equal to 210 seconds. So the displacement from A to B is 300 meter, and displacement from A to C will be 300 minus 100 meters, because he is going back to point C. So 300 meters minus 100 meters will be equal to 200 meters. And now you have to use the average speed, the formula for average speed, that is total distance traveled upon total time taken, and same way for average velocity, total displacement upon total time taken. And when you do that, you will get the answer, and make sure you write the answer in meter per second. Okay. Then Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. So initially while he was going, the speed was 20 km per hour, but now because there is less traffic, the average speed is 30 km per hour. So what do you think? What is the average speed? So you will calculate the average speed by the formula that we have discussed, that is total distance traveled upon total time taken. And when you calculate it, you will get the average speed as 24 kilometers per hour. Okay, so you have to calculate that using the formula. Then we have the next question as a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square for 8.0 seconds. How far does the boat travel during this time? So here you will have to use the formula F is equal to ut plus half at square. What will you use the formula as? S is equal to ut plus half at square. Okay, so here u will be 0, t will be also 0, because like the time is not given, right? Half, sorry, t will be 8, right? Because we have 8 seconds. But over here, because like the u is 0, and when you multiply it by that, it will be 0. So half 3 into 8 square, and you will get the answer as 96 meters. Okay, you can like do it once, and if you don't understand it, you can please like get in touch, so that you will be helped with a proper solution to it. Okay. Now see, the next question that we have is, a driver of a car traveling at 52 kilometers per hour applies the brake and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 kilometers per hour in another car applies his brake slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graph for the two cars, and which of the two cars traveled farther after the brake were applied. So I'll show you how exactly the graph will be. Now suppose this is your graph. Okay. So here you will write velocity. Here you will write time. Now time will be like 5, 10, and velocity will be, you can take the numbers. Okay. For car A, like suppose I have 5 over here and 10 over here. So for car A, it will be like this. So sorry, not like this. It's going to be a straight line. Okay. This will be for car A. And for car B, you will get somewhat like this when you plot the graph. Okay. It's going to be like touching the 10 part, and it will be from here. So this will be the graph obtained for car B, and for car A it will be like this. So make sure if you're not understanding anything, you're reaching out. Okay, now all the question that we have, I'll just let you know the formula that we can apply. Okay, so see, now we have figure 6th question as figure 8.11 shows the distance time graph of object A, B and C. Study the graph and answer the following question. Now tell me which of the three is traveling the fastest. So see, because the slope of line B is the greatest, right? So it is traveling at the fastest speed. Okay. Then are all three ever at the same point on the road? So we can see that the three lines do not intersect at a single point, right? So the three objects never meet at the same point on the road. Okay. Then third one, how far has C traveled when B passes A? Now because as you can see, we have 7 unit area of graph between 0 and 4, and on y-axis one graph unit is equal to 4 by 7. Okay, so since the initial point of object C is 4 graph unit, its initial distance from the origin will be 4 into 4 by 7, that is equal to 16 by 7 kilometers. So that is how you're going to calculate it. Okay, next thing that we have is a ball is gently dropped from a height of 20 meters. If its velocity increases uniformly at a rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? So over here you need to use the formula as v square minus u square is equal to 2as. Which formula will you use? 2as is equal to v square minus u square. You have to use that formula and calculate it. Okay. Then for 8th one, the speed time graph for the car is shown. You have to find out how far does the car travel in first 4 seconds. Shade the area on the graph that represents the distance traveled by the graph. So the area, if you will find out, like once you calculate it, you will see that this much area you will have to shade. So in 4 seconds it will travel this much, right? So you have to shade this whole area. And after that, which part of the graph represents the uniform motion of the car? So we know since the speed of the car is not changing from point 6 to 10, right? Like from here till here, the speed of the car is not changing, right? So the car is said to be in uniform motion from 6 to 10 second. Okay. Then for 9th one, state which of the following situations are possible and give example for this. An object with a constant acceleration but zero velocity. So yes, it is possible. Like suppose an object thrown up into the air. It has constant acceleration due to gravity acting on it, right? But however, it is going to reach its maximum height, and its velocity in that case will be zero itself. Okay. Then second one, an object moving with an acceleration but with uniform speed. So yes, again it is possible because we know that acceleration implies an increase or decrease in speed, right? And uniform speed implies that speed does not change over time. So circular motion is like an example of an object moving with acceleration but with a uniform speed. So an object moving in circular path with uniform speed is still under acceleration because the velocity changes due to continuous change in the direction of the motion. Okay. And for the third one, an object moving in certain distance with an acceleration in perpendicular distance. So again it is possible, and it is possible for an object which is accelerating in circular trajectory. There the acceleration will be perpendicular to the direction followed by the object. Okay. So I might be bit quick with it, but please make sure that you are going through it. Okay. And whatever doubt you have, you're free and open to come up and ask for a solution for that. Okay. Now we have the 10th question. An artificial satellite is moving in circular orbit of radius 42250 kilometer. Calculate its speed if it takes 24 hours to revolve around the earth. So the radius is given as 42,250 kilometers. The circumference of the orbit will be 2 into pi into 42,250, and that will be equal to 26,500 2,65,571 kilometer. Like once you multiply that, and time taken for the orbit is 24 hours, right? So therefore the speed of the satellite will become, like, you will be dividing it by 2. So you'll get the answer as 11,065.4 kilometer per hour. Okay. So now I'll end up with this lesson motion, but I hope whatever we discussed today in this part of the lesson, every one of you are clear with it now. Why I have not given you the solution directly, because I know if I give it, nobody will try to do it on your own. So I just want each one of you to practice all the numericals on your own, because I have like told you which formula to use for which question, right? So make sure you go through it and you solve it, and if you come across any problem, feel free to get in touch. Okay, so I'll end this part over here, and in the next part I'll start with a new lesson. Thank you everyone.